Welcome to Open Source Spotlight. We invite open source authors and ask them to show the tools they're working on. Today we have Rish. Hi Rish, tell us a few words about yourself and about the tool you want to show us.
Awesome. Amazing to be here, Alexi. Thank you so much for having me here. So I'm Rish, one of the founders here at Refuel. Quick background on me is I've been building machine learning and data systems for the past 7 years, was at Stanford before that for grad school. And we started Refuel because for a lot of machine learning teams, clean labeled data and access to that is one of the biggest bottlenecks. In my past life as a machine learning engineer, I cannot count the number of hours I've spent just labeling my own data, labeling my own cleaning and labeling on my own data. And the teams that we speak to, when they embark on a new project, they're left with two choices. Either their internal team spends many weeks labeling their data, or they work with some third party, which doesn't fully understand the nuances of their data. And there's back and forth. And still you end up with data that is not clean, that is not sufficient to train high quality models. So the goal for us at Refuel and the library that I'm going to be showing you, Autolabel, is to automate a lot of that data cleaning, that data labeling, data enrichment at or better than human quality, but using LLMs. So, any NLP task that you can think of, bring your own LLM and get labels at high quality. So excited to show you how that works and what that looks like.
Yeah, I already want to buy it because you speak to the pain I had in so many years working as a data scientist. I don't know how much time I spent working through these problems you just mentioned, like trying to label the data, trying to get somebody to label this data, and then at the end it's still a mess. So I'm really excited to see the demo.
Amazing. So let me just get started and I'll share my screen. So the first thing that we'll see is, this is our open source library on GitHub. Feel free to check it out. There's a bunch of information here and resources, even a link to our Discord community where you can go and meet more folks who are trying out the library. But let's actually jump right into the demo. So I've got a Jupyter notebook up here. Okay. So, before I even show code, one of the things that I wanted to share was, when people think about LLMs for the first time, they think about, okay, you can ask it to do stuff, but it'll hallucinate, it'll make mistakes. So as we were building Autolabel, we actually went on a benchmarking exercise. We put together this technical report where we benchmarked many different data sets, many different tasks across LLMs, and we actually even hired human annotators to go and label the same data. And actually what we found is state-of-the-art LLMs, and GPT-4 is the best model that is out there, they can label data sets at the same or better quality compared to skilled human annotators. But the wins that you get are, it's 20x faster, in some cases 100x faster, and cheaper as well. And GPT-4 performs the best, but if you also want trade-offs across label quality and price, you can pick some of the slightly cheaper models like GPT 3.5 Turbo, or even open source models like Planty5. So we saw these results for different LLMs against humans. And then the time taken, it's kind of a no-brainer. You can imagine LLMs are just much faster labeling this data. So feel free to go check out the sort of technical report, and also it's on our website. But time to actually look at actual code and the real problem that a machine learning person might be trying to solve. So the example that we have here is imagine you're working at some social media company or some platform where there is user comments that are coming in. And one of the biggest challenges for these teams is you want to detect which are toxic comments. If you have content moderation, which ones you should be taking down, and you want to train models based on the policies that your team internally might have. So what might happen here is your policy team might give you 100 examples of things that they think are toxic or not toxic. But actually, you probably have like a vast number of unlabeled examples. And to train any model, you first need to go from that 100 labeled examples to maybe a few thousand. So until now, the way to do it would be, again, you spend a few weeks labeling data yourself. But I'll show you today with Refuel how you can do that in 30 minutes, right? Very quickly get thousands of labeled examples. Okay, so that's what the problem statement is. To get started with Refuel, it's fairly straightforward. You just do a pip install. We'll be using OpenAI and their LLMs for labeling, so you'll have to plug in your own API key here. I've already provided my own. This specific data set, we actually provide that within Autolabel itself, so you can actually just go and download it. But actually, let me just show you what this data looks like. So, some of the labeled examples basically look like this, where you've got an example comment, and we've got some labels of toxic or not toxic. Okay, and the goal will be to label a much larger data set that is completely unlabeled. Okay, So let me actually walk you through, basically labeling with Autolabel is a 3-step process. The first step is, we define this labeling configuration, and I'll walk you through what that configuration looks like. The second step is almost doing this dry run, giving this data set to an LLM and understanding how much it'll cost, how much, what the prompt will look like. And so this is this dry run step. And the final is this labeling step. And as we go through this, this labeling process, you'll see that we'll go through many different experiments really quickly. And the goal will be to try to get labeling accuracy to be as high as possible. Okay. So let's look at this configuration really, really quickly. Okay. So what we're seeing here is, we're looking at a classification task. We're going to be using GPT 3.5 Turbo for data labeling. And maybe we give it a very simple prompt, right? A very simple guideline, which is, hey, does the provided comment contain toxic language, right? Just answer that question. And we say that, these are the 2 labels, and let's run this. And so now this plan command, if I run this now against our unlabeled data set, it'll very quickly tell us that, okay, I found 2,000 examples in the data set. This is the estimated cost of using this model against the data set that we have, right? So you can see it's pretty cheap. And it'll also show you the exact prompt that would get sent out to the LLM, right? So this is the guideline that we'd specified above. This is the example that is being fed in, and we're asking it for an output, right? So fairly straightforward. There's some, we've basically simplified how that final prompt gets created, but you actually get visibility into what that actually looks like. Okay, now let's actually go and label it. So we're going to label about 100 examples here. Now this will take, about roughly under a minute, maybe about 20, 25 seconds. So we'll just wait for this to complete.
How many iterations did you make on these prompts?
It's a good question. I mean, you can see that the first example that we have is super straightforward. And actually, what I'll show you is that this prompt is actually not very good. And the interesting thing is how Autolabel makes it easy to iterate through different techniques and prompts to get to very high accuracy. So we'll actually walk through what that process almost looks like. Okay, so it looks like we've got results back. So, it finished pretty quickly. But the interesting thing that you'll notice that the accuracy, and reminder, right, we had 100 examples that were labeled by our policy team. So over those 100 examples, the accuracy isn't very good. We've only hit about 56% accuracy, right? That's not good enough if we want to train models on this data set. So the next thing that we might want to do is give the LLM some examples, right? Similar to how human labelers require examples, you want to provide them examples of what is good and what is bad. The same thing works with LLMs as well. So how would we do that? Well, it's a very simple change to the same configuration. So everything else remains the same. And all we do is we say, hey, here are 4 examples of what is toxic and what is not toxic. Okay, so all we say is, these are the 4 examples, always pick those 4 examples and just fix those 4 examples. And now I'm not going to run this entire thing again. You saw that that workflow. The plan process remains very similar. The cost goes up. The cost goes up a little bit because now we're actually giving it examples. So you can see that here's an input, output, input, output, input, output, and then we're finally asking it to label. But now when we label this example, the accuracy now jumps from 57% to 70%. So we're seeing, just adding a few examples helps the process so much. But again, 70% isn't very good. We want this number to be 90% or even higher. So what do we do next? Well, Alexi, coming back to your question on, how do we iterate on the prompt itself? Well, the process of running this labeling, it produces an output data frame, which actually contains the labels that came from the LLM. So let's actually look at that output data frame. And, if I run this now, you can see that, here were some examples. This was the original ground truth label. This was the thing that came out of the LLM. And essentially, you can review this and figure out, for example, by comparing where the label wasn't the same as the ground truth, where mistakes were being made, right? So now, we've done the work of looking through these examples, figuring out some of the trends and the error analysis required to figure out where the mistakes were being made. But you can do this error analysis, and then let's say we come up with a slightly longer, slightly better prompt, right? So here we're not just saying, hey, is it toxic or not? But we're explaining what does toxic actually mean. in the context of what we're looking for. And typically, if in the policy teams here, they have a very good idea of what does toxic mean, what does toxic not mean. So again, now we're not changing anything else. We're keeping the same set of examples, and we've added a slightly longer description, right?
So
and now we run the.
Took quite a few iterations, right?
It took 2 to 3 iterations. And again, because we're doing it with 100 examples, the nice thing is the feedback loop is still, it's a minute, right? You run it, it takes a minute to get 2 examples, and you can quickly iterate and improve. But yeah, I think, in terms of if the task is very complex, this might take a little bit longer. Okay, so, let's say we have this slightly longer, guideline that goes in here, similar examples. And this time, the accuracy actually jumps from 70% to about 77%, right? So we're seeing this kind of, movement in terms of, labeling accuracy. We started with 57, went to 70 with adding some examples, 77 with better prompts. And the other thing that you can switch out now is just choosing a different LLM altogether. So far we've been using, GPT 3.5 Turbo, which is, the cheapest model that OpenAI has to offer. GPT-4 is the best. We won't use that right now. We'll use something in the middle, which is Text DaVinci. And again, nothing has changed. All we did was one line that got switched. We run the entire thing again, right? You'll see that the cost has gone up because this is a more expensive model. But the accuracy now jumps to about 89%. So all of these experiments are just very quick changes to configuration, and we get to see sort of improvement in performance. Okay, I'll pause here. Alexei, see if you have any thoughts or questions.
I was wondering about the cost. So the cost was $53 per 2,000 examples, right?
That's correct.
Okay.
And this was actually significantly higher than GPT 3.5 Turbo.
7 times higher, right? Is it still cheaper than crowdsourcing, or it's more better quality, or?
So this is still way cheaper than crowdsourcing. Actually, if I go back to the very top, where we had this chart, typically like the cost per label for if you hired sort of humans, it would be somewhere in the 10 cents per task, right? Whereas, we're looking at like, under a cent for Text DaVinci. So it's still super, super cost effective.
Yeah, thank you.
Okay. Any other thoughts before I jump into the next topic, which, okay. So again, so far, just to review, right? We've experimented with prompts, with examples, with LLMs, and we're seeing this continuous improvement in accuracy. The final thing that, we're building and we're pretty excited about is almost this ability to assess the confidence in the output of the LLM, right? Now, LLMs, you feed them some data, they'll produce some output, but how do we know that they know what they're talking about, right? And so confidence is like a very, useful measure, because if we're able to get high quality confidence scores for each label, we can almost plot charts like this, where, there's a different operating point for what accuracy, what performance we want in terms of, labeling quality, and how many examples, let's say, we reject, or how many examples we accept. So we might take this trade-off of, not labeling everything, but the ones that we take in are much higher accuracy. Okay. So in order to compute confidence, actually, the way we do it is there's an LLM that we host, at Refuel, and you can sign up for that. You can get an API key. And the one line change that you'll have to make is you'll have to just add this one line which says compute confidence is true. And if you do that, everything else remains the same. You run .plan to get the same prompt. But when you run the labeling, you don't get a single accuracy score. You get different accuracy scores based on what threshold you might want in terms of performance. So let me help you out. Let me walk through this particular table here. Let's say we wanted to label 100% of the data, right? That would give us, let's say, 75% accuracy. But if we wanted high accuracy, we wanted something like 95% or greater, right? Essentially, we could label 73% of our data and get upwards of 95% accuracy. So we get to pick almost, what operating point we want to be at. And given that, this team, right, that has social media comments, they probably have millions and millions of examples. right? You're okay to label a lot more and then reject the lower quality ones so that you can train your data set at a much higher data set quality, right? And as always, you can just look at the output that came from this labeling exercise, and you'll not just see the label from the LLM, but you actually see confidence scores. So you can see that, for example, this very low confidence score was actually mislabeled, right? And so it's an example of being able to reject the ones that we don't have high confidence in.
Are there open source LLMs that can do that? Or is your LLM, first of all, is it open source or something that you...
So at the moment, we're basically using an open source LLM to produce these confidence scores. But you can imagine that it's possible to build more specialized LLMs that can do this job even better.
Okay. So technically it's possible, let's say I have my own LLM that does do this. Can I plug it in and use it in...
Absolutely. I mean, if you have like an LLM that you've used, that you have trained internally, and maybe it's using sort of Hugging Face, I'll just quickly walk through our documentation. You can basically pick whichever LLM that you want. So everything from OpenAI to anything that you might have trained and that you might have even locally, as long as you can plug it in through it's been trained using Hugging Face transformers. And all you have to do is just specify the name of the model here in the configuration.
Oh, awesome.
Yeah, so the goal really is with Autolabel, any data set, any NLP task, the LLM of your choice, and get high quality labels out.
That sounds really cool.
Awesome. And yeah, just, we can probably, demo-wise, we can probably stop here. But yeah, the end goal really, hopefully the thing that would have taken a week, if not more, to label those, 2,000 examples, you can see it run very, very quickly and at very high accuracy.
Okay. Do you have more notebooks like that, like this demo, that we can just go and check?
Absolutely. So, the specific example that I shared, you can go to our documentation. Here's a tutorial for that toxic comment classification. And the live working code is available in Colab here. So if you click through on this, you'll be able to find examples here. But if you go through more of our documentation, every single page has sort of examples in there. So let's say you wanted to do multi-label classification and not just output a single label, but output multiple labels. There's an example here that you can play around with in Colab. If you wanted to do NER, named entity recognition, there's an example for that here. So there's plenty of examples in our documentation.
Yeah, thanks. How many people are working on this?
Yeah, good question. So, we're a team of 8 people at Refuel who are building this. But the amazing thing is after we've open sourced this, we've got a fantastic community of contributors. So the number of contributors is much higher today than the 8. And we've got a Discord community with a few hundreds of people who are actively working and contributing ideas and contributing code.
If somebody wants to contribute, they should go to your Discord, right? Or what are the
Absolutely.
steps?
So, if you want to help, if you want to contribute, first, check out our open source library. Feel free to open issues directly in here. We have a Discord community. You can find the link at the bottom. And then, we have specific kind of instructions, everything from what types of issues that you can open and what types of issues you can go help fix for us.
Do you have good first issues?
Yeah, actually, let's check it out. I think we should. We've got plenty of issues that would be interesting. And so I think first, we've definitely got a few good first issues in here.
Mm-hmm. Cool.
Yeah.
Do you plan to take part in Hacktoberfest this year?
Tell me more. I actually don't know about Hacktoberfest too much.
Okay. So this is like Oktoberfest, but instead of drinking beer the entire month, you help open source projects. So people just go there. So there is a company behind it who organizes, who gives some incentive for people to take part. All you need to do is an open source tool. You just need to add special label, Hacktoberfest. Then it becomes discoverable and people can just contribute it. And usually what companies do, they also announce it on social media and then people retweet it. And so it's a very cool thing. So I do suggest to take part. Last year,
that sounds like a wonderful idea.
It is a wonderful idea, and people are quite excited. Even so we at Datadocs Club, we have a few projects that are not tools, but we have a few repos, and people would, even without labels, they would say, okay, I'm doing Hacktoberfest, I want to fix this issue. And they would contribute. That's amazing.
Amazing.
Yeah. So do take part. Okay. What are your plans? What do you want to do next?
So, with Autolabel, our goal really is we want to be able to continue to support many new NLP tasks, many new models that are coming out, especially there's a lot of interesting open source models that are coming out. And frankly, with LLMs, there's so many new techniques, new ideas that are being discovered, yet to be discovered. And we want to make it easy for folks to be able to contribute those ideas, to be able to contribute to even the benchmark that we're sort of putting together. The benchmarking report that I shared. So there's, with LLMs, there's really just there's a sort of wealth of knowledge that is waiting to be captured. So yeah, we're just always on the lookout for new techniques that might help improve labeling performance, new LLMs that might be doing well for maybe specific types of tasks. Yeah, and always just kind of making this better. And one of the actually concrete things that we'll be doing is making the error analysis workflow a lot more easier, so that the prompt improvement that you mentioned at the beginning, Alexei, that can be even faster. And so you can imagine there's sort of a lightweight UI that we'll be releasing here as well.
Like widgets in Jupyter, right?
Widgets in Jupyter, or maybe even sort of like an app that you can run locally.
Like something like Streamlit or something similar, right?
Yeah.
Interesting. And while you were talking about your plans, a thing popped up in my head. Does it only apply to NLP tasks, or I can also use it for tabular data?
That's a great question. You can actually absolutely use this for tabular data today. So one of the things that, and we didn't show this in here exactly, but any of these task guidelines, you can actually template in different variables. And so you can imagine that the CSV might have different columns. You can just template in the column names, and you can construct the prompt exactly however you want. And we've actually seen really good results even for tabular data, where there's 10, 15 different columns that are being plugged into the prompt. Was there a specific problem that you had in mind for tabular data?
I don't know, Titanic. Or
Yeah.
I don't know. Well, it could be interesting to see. I guess like you can format this as JSON, and then LLMs are typically smart enough to figure out like what to do, how to parse this JSON.
Yeah.
Interesting. Okay. Well, last question. Do you have any advice to anyone who is watching this?
Yeah, I think I'd say two things. We're living in an interesting time where LLMs are dominating a lot of sort of conversation. The first thing I would say is, even though there are all of these APIs from OpenAI and Anthropic and Google that are available, but there is really no substitute to working with your own data, trying to train some lightweight models, and getting a feel for what does that process actually look like, what performance you can hit. And so I would always encourage folks to get a feel for that. Pick up some code from Hugging Face and try to train models on your own data. Because that's a really, really good way to learn, what is possible. And the second thing that I'll say is, I think LLMs are best used in their capacity as almost teachers, or sort of, creators of this data, which is why, we're building something like Refuel, where, almost you should be explaining to LLMs, hey, here's the type of data I need. Here's the data I need you to create for me, because this will help me train my own models. And that sort of teacher model of looking at LLMs is, we're going to see that happen more and more over the next few years. And that first thing that I mentioned, which is training your own models and getting a feel for that, it will just drive that and make that a lot more efficient. So yeah, it's two-sided advice on playing with LLMs, getting a feel for them to label data and clean data and create data, but then training your own models gets the best accuracy, best performance in many ways.
You know a good tutorial about training or fine-tuning our own LLMs, like open source LLMs?
Yeah. Oh, there's a few on, and when you think about LLMs, are you thinking about for what purpose? Are you thinking of like a chat type LLM?
Well, just in general, let's say I don't know anything about that, and I am so excited about this because I use ChatGPT and I see how awesome it is, and I just want to understand, well, I have a more specific problem and I want to take an open source model and fine tune it to solve this problem. What do I do?
Yeah, I think Hugging Face probably has a few good tutorials here. I'm happy to find up a few links and send them over.
Okay, we will make sure to include them in the description. Okay, thanks a lot for joining us today, for doing the demo. What you work on is really amazing. That's really good that you put this all in open source, that people can just go grab it and benefit from this immediately. So thanks for doing that. And yeah, amazing.
Awesome. Thank you so much for having me. This was really fun, Alexei.
Thanks. See you soon.
Awesome.
Bye, everyone.
Bye.